Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to discuss about the question bank of PGP message format generation, PGP message format and PGP message generation and reception. So before going to explaining about the PGP message format for the generation of the message as well as reception of the message, we have to know that what is meant by PGP. We have to know that what is meant by PGP. So PGP stands for what? Pretty good privacy. Pretty good privacy, which is an encryption program. Which is an encryption program that provides a cryptographic privacy and authentication for data communication. So PGP is a pretty good privacy is an encryption program or encryption system. You can call it as encryption program or encryption system that provides cryptographic privacy. It provides what? Privacy and authentication. For what? For data communication. For what? For data communication. So, which is an encryption program or encryption system with the help of different cryptographic concepts. So, the main aim is to provide the privacy and authentication for the data communication. So, PGP is used for what? For signing purpose, encryption purpose, and decryption of the text as well as emails, as well as files, directories, whole disk partitions, and to increase the security of email communications. To the security of email communication. So, to writing the files, to writing the text, to writing the mails, to writing the directories, for everything, we have to provide a privacy and authentication. Privacy and authentication. So, to increasing the privacy and authentication in the mail communications. So, PGP is an encryption system used for both sending encrypted mails and encrypting sensitive files. So, both we can use it for sending encrypted mails as well as encrypting sensitive files. So, we can encrypting mails as well as we can encrypting files also. So, files and mails has to be encrypted. So, the popularity of PGP is based on two factors. Popularity of PGP is based on two factors. One is that what the system was originally available as a freeware. The first is the system was available as a freeware and so spread it's rapidly among users who wanted to extra level of security. So, those who wanted to provide an extra level of security for their email conversations or file conversations. So, this is the basic technique. This is the encryption technique that keeps your files and mails to be privacy and authentication. That keeps both privacy and authentication. So, the second is that what? Since PGP uses both symmetric encryption and public key encryption, it allows users who have never made to send encrypted messages to each other without exchanging their private encryption keys. So, the first one is what? They have to use a freeware software to communicating secure communicating mails or files in the secure process. And the second one is what? Applying the symmetric or asymmetric or public keys for doing encryption and decryption process. We have to use that keys. So, using the freeware as a software, using the software as a freeware, and using the different keys for the encryption and decryption purpose, the popularity becomes high for the PGP service. So, how does PGP encryption works? So, we already said that what PGP became popular because of the two reasons. One is what? The software is acting as a freeware And the second one is what? Applying keys, applying encryption or decryption keys for encrypting your mails or files. So because of these two, the PGP becomes high priority and high service. So how does it actually works? How the PGP works? So PGP shares some features with other encryption systems which you may have heard or like Kerberos encryptions or SSL encryption. So like that, the PGP is also working as encryption. All the data which is entered on that service will become encrypted data. Will become encrypted data. So at basic level, the PGP encryption uses a combination of two forms of encryption. One is what? Symmetric key encryption and public key encryption. Symmetric key encryption and the public key. That is nothing but asymmetric key encryption. Asymmetric key encryption. So we can use both keys, symmetric keys or asymmetric keys, for doing encryption and decryption process, for writing your mails, for securing your mails, for writing your files, for securing your files also. So this is the way the PGP encryption works by processing it and by sending the mails towards to the destination. So with the help of these four keys, the PGP makes better privacy and authentication services for all the mails and the files. So what are those four types of keys actually? So first one is what? One-time session keys, one-time session symmetric keys. And second one is what? Public keys. Second one is what? Public keys. And third one is private keys, private keys. And the fourth one is passphrase based symmetric keys, passphrase based symmetric keys. So here three separate requirements can be identified with respect to these keys. What are those requirements? Because for utilizing these requirements, these four types of keys are required. These four types of keys are managed. So what are those requirements? So what are those requirements? The first requirement is what? A means of generating unpredictable session key is needed. A means of generating a separate or unpredictable session key. Unpredictable session key is needed. So unpredictable session key is needed for key management purpose that is used for generating encryption keys as well as decryption keys. And second one is what? We would like to allow a user to have multiple public key or private key pairs. So we would like to allow a user to have multiple public key or private key pairs. So maintaining the key pairs, either public, private key pairs has to be maintained. As a result, there is not a one-to-one correspondence between users and their public keys. So there is not a one-to-one correspondence between users and their public keys. So some means is needed for identifying particular keys. And each PGP entity must maintain a file of its own public or private key pairs as well as file of public keys of correspondence. So for every PGP entity must maintain a file of its own public and private key pairs. Public and private key pairs. So for public keys it maintains separate file and a private key it maintains separate file. And also the pair of those public and private keys also maintaining a separate file. So because of maintaining all these requirements, this PGP offers those types of keys like one-time session keys, public keys, private keys, and passphrase based symmetric keys. So how the session key generation actually? So what is the purpose and how is session key is generated? So each session key is associated with a single message. The session key is associated with a single message and is used only for the purpose of encryption. And it is only used for the purpose of encryption and decrypting the message. So the key whichever used for doing encryption and decryption process, the key which is generated as a session key, that is neither public key or private key. So that is used for doing for the encryption and decryption process. So recall that message encryption or decryption is done with a symmetric encryption algorithm. With a symmetric encryption algorithm. So there are two types of algorithms actually. So one is symmetric key encryption algorithms, and the second one is what asymmetric key encryption algorithm. Symmetric key encryption algorithm and asymmetric key encryption algorithm. So symmetric key encryption algorithm, here the keys which are used in that algorithm for encryption and decryption process, we can use same key. We can use same key that is public key. We can use same key that is public key for both encryption and decryption process. For both encryption and decryption process, we are using same key. So that is nothing but symmetric key encryption algorithm. And asymmetric key encryption algorithm, for encryption process we are using public key, but for decryption process we are using private key. For decryption process we are using private key. So encryption process we are using public key. The different keys are used for doing the process of encryption and decryption. So that it is called as asymmetric encryption, asymmetric key algorithms, asymmetric key encryption algorithms. So here the input to the random number generator. So how actually encrypted key is generated? How that key is generated? So the input to the random number generator is a function. Random number generator is a function. The input to that function having a 128-bit key. This is a random number using the keystroke input from the user. So the user entered input from the keyboard that is taken as a input to the random number generator, and it consists of 128-bit and two 64-bit blocks, that are treated as a plain text to be encrypted. So using CFB mode, so comments for base mode, two 64-bit cipher text blocks are produced and concatenated to form the 128-bit session key. So to generating encryption key, session key 128-bit. So using CFB mode, two 64-bit cipher text blocks are produced and they can concatenated. So the algorithm that is used is based on the specified ANSI x12.17. So based on the different algorithms, the session key is generated. So if it is 128-bit, if it is 64-bit, if it is 32-bit, based on the input to the random number generator, the key will be generated. Suppose in the real time, the IDEA algorithm generates 128-bit key, but RC4 algorithm generates from 8 bits to 128-bit key encryption keys. So IDEA algorithm generates only 128-bit key, but RC4 generates from 8-bit key to 128-bit keys, encryption keys are generated. So like the way session keys are generated with the help of algorithms which are given as input to the random number generators. And key identifiers. So key identifiers that indicates that the IDs are maintaining for the pair of both public and private key. So maintaining for the public and the private key pair per user. So here it is possible to have more than one public or private key pair per user. Yes, it is possible. It is possible to maintain one or more public-private key pairs. Each one therefore needs an ID of some kind. So that means each and every public and private key pair maintain ID. Each and every public and private key pair maintain one ID. So that ID is associated with each public key consists of at least significant 64 bits. Its least significant 64 bits. That is the key ID of public key KUA mod 264. Mod 264 bits it has to be maintained. And this is a sufficient length. This is a sufficient length that the probability of duplicate key ID is very small. Sufficient length that the probability of duplicate key ID is very small. So a key ID is also used for the PGP digital signature, as the render may use one of number of private keys to encrypt the message digest, and the recipient must know which one was used. Which one was used. So with the key ID concepts, we have to understand a more detailed look the format of transmitted message as shown in the next figure. So the message format is to be shown in this figure. So here the general format of PGP message. So each and every PGP message consists of what? Public and private key pairs. Public and private key pairs, which is generated from the session key component. So here we can understand that this is the content and this is the operation. So here the notations which are using like E, K, U, B as a encryption with user B's public key. So there are two users, user A and user B. User A and user B. Suppose we are thinking about transmission of the data occurs between user A and user B. So user A. So here E, K, U, B indicates that what? Encryption with users B public key. Encryption with users. So here E stands for encryption and K, U, B stands for public key. Encryption with users user B's public key. And similarly, encryption with K or A, that is nothing but encryption with user A's private key. Encryption with user A's private key. So this indicates that what? Private key. And EKX. So EKX indicates that EKS, that indicates that what? Encryption with a session key. Encryption with a session key. And a zip. So this is the zip compression function to reduce the length of the message to convenient space, into the convenient space. And R64, radix R64 conversion function. Rad R64 conversion function to dividing a large message into a number of blocks. It is used. So here the message format contains what? A session key component, and then next signature, and next message. Signature and message. So here the session key components generates what? Public key or session key or private key. So here each and every public key and the session key is maintained with the key IDs. So here the key ID of recipients. So for the public key and for the session key. That indicates that what? Encryption with user B's public key. Encryption with user B's public key. And the second part, the timestamp key ID of sender's public key leading 2 octets of message digest and message digest. So here the EKRA, it indicates that what? Encryption with users A private key. Encryption with users A private key. So this all is nothing but encryption with message private key. And the file name and the timestamp of the file and the data contained in the file. So all these will be applied with the zip function. So to compressing, and the next session key is generated. The next converting into the small block. So this is the operation. First it has to be compressed, then it has to be converted, it has to be generated with the session keys. So compression, encryption, then next do the process of dividing segmentation. So compression is here, the next session key is here, key generation is here, the next segmentation is here. So this is the operations are executed on the public key and private key pairs for the PGP message as a service. PGP message as a service. So here the each and every PGP message has to be transmission, and how the PGP message has to be transmitted, and how the PGP message has to be received. So how the PGP message has to be transmitted and how the PGP message has to be received. So here it has to be followed three functions, like one is what a signature, digital signature is required or not, the next compressed or not, the next confidentiality is required or not. So if it is required, then it has to follow with the digital signature process, compression process and the confidentiality process. That is nothing but encryption process. If it is not required, then without following them, the file has to be sent to the destination side or receiver's mail address. Receiver's mail address. So now we can see before sending mail to the recipient, what the process is occurred in the transmission. So here, the file, if the file is required with the digital signature, yes, then apply generate a signature to that file, generate signature, digital signature to that file. Yes, after generating that file, it has to be compressed. It has to be compressed with the zip compression function. After that, the compressed file, after the compressed file, if the confidentiality required, if the privacy is required, then process the encryption keys. Process the encryption keys. That is nothing but applying encryption key to the particular file. Applying encryption key to the particular file with the help of some encryption keys algorithms. With the help of some encryption keys algorithms. If it is not required, then you can directly send to the mail. So now the file is encrypted. Now converting the file is into a segmentation process, dividing the blocks. The next, after conversion, it has to be sent to the receiver's mail address. It has to be sent to the receiver's mail address. Receiver's mail address. So now the file is file contains both privacy and authentication mechanisms. Now the file contains what? Both privacy and authentication mechanisms, because all the digital signature is applied to the file, compression function is applied to the file, encryption process is also applied to the file, and dividing segmented process is also applied to the file. So now the file is ready to send to the destination side or receiver side. So after receiving at the receiver side, what receiver has to do? After sending to the receiver mail address, what the receiver has to do to open that file. So he can convert it from radix 64 to normal way. The next, if the file is confidential file, then it has to be decrypted. It has to be decrypted. It has to be decrypted with the help of decrypt key. With the help of decrypt key. So the decrypt key is applied here. The key is applied. After applying the key, the file has to be decrypted. The file is to be decrypted. Now apply decompress process. So apply decompress process. So after applying decompression process, it has to be verified with the digital signature. It has to be verified with the digital signature. So if the file is a digital signature file, it has to be verified with the digital signature. Then next, open the file directly. Open the file to see the contents. Open the file to see the contents. So this is what happening in the real time to writing secure emails in between the two systems or two users. So before sending, the file is to be required with the digital signature. The file is to be compressed and the file is to be encrypted. After doing all these processes, the file is converted. After doing all these processes, the file is sent to the receiver mail address. Now the receiver got mail and receiver has to be converted from radix 64. Then next, decrypting that file. Then next, decompressing that file. Then next, verifying the signature of that file. After that only you can able to see the contents of the file. After that only you can able to see the contents of the file. So this is the way of performing the transmission and reception of the PGP message. And what is the PGP encryption uses? So what are the main use of using this PGP as a service? So what is the main use? So there are essentially three main uses of PGP. Three main uses of PGP. One is what? Sending and receiving encrypted mails. Sending and receiving encrypted mails. The first one is what? Sending and receiving encrypted mails. And second one is what? Verifying the identity of the person who has sent you this message. So you can see the identity of the person who has sent you this message. So third one, encrypting files to be stored on your device or in the cloud. So all the files has to be encrypted, which are stored on the device or cloud. So these are the three main uses. Because of these three uses, because of these three services offered, the PGP becomes more popular in the writing of secure emails. Popular in the secure emails. So this is what we have to understand: the PGP message format, and the message, how the message is to be generated and how the message is to be received by the receiver side. So this is what we have to understand from PGP message, and how we can see the contents. We can revise the contents which we are discussing in this session. So here, what is the PGP? What is meant by PGP? So how can we define it? PGP is a encryption program or encryption system that provides what? Privacy and authentication for data communication. It provides both privacy and authentication for data communication. And this PGP is popular because of the two factors. One is what? It is available as a freeware, and we can use different keys for doing encryption and decryption process. Because of these two processes, because of these two, the PGP becomes popular. So how does PGP encryption works? So it works for based on the symmetric keys and asymmetric keys algorithms. So applying encryption on the file, applying encryption on the mails. So after encrypting that file or encrypting that mails, it has to be received by the receiver, and then decrypting the file and decrypting the mails to see the contents of the file. So because of that encryption and decryption process, the message integrity will never lose. Message integrity will never lose. So what for doing encryption process, what are the types of keys we are using? So one is one-time session symmetric keys, and the second one is public keys we are using, private keys we are using, and passphrase based symmetric keys also we are using. So session key generations. So public keys generation, private key generation, applying algorithms, symmetric keys or asymmetric keys algorithms with the help of their bit keys length, and the key identifiers. So generating after generation of the public keys and private keys, maintaining key IDs for each and every public and private keys is a separate identify process. So here we can understand the PGP message format, which contains the session key components, signature, message, and timestamps, public and private key pairs. So all the notations we have to understand. The operations performed on the PGP message is what? Compression, encryption, and the segmentation process. With the help of these three operations, we are performing sending and receiving mails by writing secure emails. So here, the file before sending a file to the receiver's address, the file is to be verified with the digital signature, and then compressed, then encrypted. After then, it has to be segmented, then move to the receiver's address. Once the receiver received that mail, the receiver has to be decrypted that file, decompressed that file, and then verifying the digital signature, then it see the contents of the file. So this is what the in the real time the mail communication process will happen for the secure emails. And the last, the PGP encryption uses. So what are the uses having for the PGP encryption? So sending and receiving encrypted emails is the first uses. The next, identity of the person who sent to you the message, and the files which are stored on the device or cloud are always encrypted. So this is about PGP encryption, PGP message format encryption, and generation of the message and reception of the message and encryption uses. So this is all about two PGP message services or PGP message format generations. Thank you all.
Like, share, and subscribe. Hit the bell icon for more updates.